Today we're going to talk about simplifying expressions. We're going to talk about identifying terms, and this says numerical coefficients, but I just call it coefficients. We're going to talk about identifying like terms, combining like terms, and then this last one we're actually going to take out. So because it's not going to be on your test, and yeah, it's kind of difficult. Okay, so the first thing we did in class today is just we talked about simplifying each expression. So on Friday in lesson 1.6, we talked about different properties. So we talked about the commutative property, which we're going to talk about again today. We talked about the associative property. We talked about the identity property, the inverse property, and then finally something called the distributive property. So we're going to use the distributive property here. So we're going to distribute that 5 there and distribute that 5 there. So that I believe that 5 times 4x is 20x. And then 5 times negative 3y should be negative 15y. And that's going to be your answer. We're going to talk about today why you can't combine those. And yeah, because those are kind of what we call unlike terms. We're going to talk about that here in a second. So anyways, so that is all that for that one. This is one that if you want, this is one if you want to pause the video, you can try this one out, and then I'll explain kind of something. They actually combine like terms here. A little early for me, but anyways. So go ahead and pause the video and take a shot at this one. Okay, so I think we're going to distribute the negative to there and to there. Now be careful. Negative 1, there's technically a 1 here. Negative 1 times 7 is negative 7. And then negative times a negative, remember, becomes a positive 6k. And then you have a plus 9. So I'm okay if you leave it there. That's all I asked you to do. And we'll talk about what it truly means to simplify here. But I think if you look forward, I think you have a negative 7 and a 9 here. You can combine those. Negative 7 plus 9 is going to give you 2. And then we're going to have this 6k as well. And then we're good to go. So that's kind of where, I mean, like I said, I'm okay with it stopping there. What they did here, just to kind of give you an example, this is kind of the book's way of doing it, is they recognize that this negative 7 and this 9 were what we call like terms, kind of like we did. So what they do is they actually move them. And if you guys remember, the reason why you're able to move those from last week is the commutative property of addition. Because remember, you can move things around as long as they're all addition. It doesn't matter in which order you have them. So then from there, they simplified it to the same thing that we got. So hopefully that makes sense. Okay, so I want you to go ahead and pause the video here, and I want you to copy down these definitions somewhere, or you can just read them and refer to this video later, or the PowerPoints are on the MyUSF site. So this is their definition, this is my definition, this is their definition, and this is my definition. I'll explain it in a second. This is riveting stuff.
Wait, did you just end the video right now?
No, I'm still recording. Okay, so what is a term? There's lots of math words up here. So it's a number, a constant, a variable, a product, or quotient. So basically, if you remember this, you're good. So terms are often separated by some kind of operation. So whether it's a plus sign, or a minus sign, or a multiplication sign, or a division sign, it doesn't matter. And I'll show you some examples. So here are some examples of terms, but I'll show you later kind of what that looks like in a math problem. And then the coefficient, basically the way I think about a coefficient is it's the number in front of the variables. So in this term 9x, the coefficient is just 9. In this term 15y squared, the coefficient is 15. The coefficient here is technically negative 3. And this one's negative 8. This one is probably the one that's going to confuse a lot of people, and I'll kind of explain why in a little bit, but there is technically a 1 in front of there, okay? And so if we ask what the coefficient is, we're going to talk about a 1, okay? All right, so that's terms and coefficients. And a lot of times when we talk about, this is going back to the very first problem, I think it was 20x minus 15y, why we can't combine those. So we're looking for something called like terms, okay? So in this sense, 9t and 4t are what we call like terms because they both have the same variable, where 4y and 7t are unlike terms. So we couldn't combine those. Here, we can combine these to get a 13t, right? Here, 6x squared and a minus 5x squared, those are like terms because of the x squared and the x squared, right? Here, I have an x and an x squared. Those are unlike terms, okay? Down here, This is where I'm going to ask a trick question. So I've got a negative 2 PQ and 11 PQ. And obviously this chart tells us that those are like terms, so those are okay. My question for you is a negative 2 PQ and 11 QP, are those like terms? I'll give you a couple seconds to think through it. The answer is yes, those are like terms. Why? Goes back to Friday's class when we talked about the commutative property. So we know that negative 2 times P times Q is technically the same as negative 2 times Q times P, because multiplication is commutative. So these two would be like terms, just like this one. If I change that to a yx squared, sure, those are both like terms. X squared y and yx squared are like terms, commutative property. Difference over here is you have an xy squared and this is an xy. There's no squared up here, right? So those are unlike terms. This is a wz cubed where this is an xz cubed. Again, this w and this z, unlike terms. Okay? So for like terms, they have to have the same variables with the same exponents. Hopefully that makes some sense. So what I'm going to talk about is the first one. If I asked you in A how many terms there are, how many would you say? Well, I see a term of 5z, I see a 9z, and I see a negative 4z. So I'm counting those as 3 different terms. So then, combining them, I think I can combine these first. Now, this is what I said in class, and this is really true. One of the hardest things in algebra, honestly, is determining the difference between x plus x and x times x. If I asked you what x plus x was, what would you say? Hopefully you would see that x plus x is 2x, where x times x is really x squared. So those are two different things. So when I take a 5z and I add a 9z, I'm only going to get a 14z. Oftentimes I see 14z squared. I might see 45z squared. But I basically think of the variables as like an apple. So I've got 5 apples here. I've got 9 apples there. When I combine those two, I'm going to end up with 14 apples. Okay, so I'm going to subtract a 4z from here. And again, if I have 14z minus 4z, I think that's going to leave me at 10z. Go ahead and try 1 and 2. Okay, 4r minus r. Remember, like I said in the last slide, there's technically a 1 here. So this is just going to give me a 3r. And then, number 2, I tricked you. So this is an 8p. This is an 8p squared. Those are unlike terms. So those cannot be combined. So those you literally are going to leave as 8p plus 8p squared. It's okay. We had a lot of people try to combine those and make those 16p cubed. We had a couple people do 64p cubed. Remember, honestly, this thing right here, remembering that is huge. So x plus x just gives you 2x, and x times x gives you x squared. Those are huge. That's kind of one of the fundamental things of algebra. If you honestly can get those separate in your mind, you'll do okay. All right, so simplifying an expression, 3 things. I wish I had these numbered. So number 1, when we see an expression, in order to simplify it, we have to do 3 things. The first thing is all grouping symbols must be removed. Most of those times, those are going to be parentheses. So I'll explain that in a second. Number 2 is all like terms must be combined. And number 3, operations have been performed when possible. And we're not going to get to an example of that today, but I'll kind of show you what that means. All right, so let's walk through this. Step 1 back here says all grouping symbols have been removed. So in my mind, I'm seeing these set of parentheses right here. How do I remove them? Well, I technically have a negative 1 here, right? I can distribute there. I can distribute there. So I get a negative 3. Now remember, this is the negative 1 times positive 5k. So that's minus 5k. And then I'm just going to bring down this plus 7k. Okay? So that's step 1. Did I get rid of the grouping symbols? Of course I did. Step 2 says all like terms have been combined. So I see a negative 5k and a 7k there. I think that's going to give me a 2k. And then there's no other like term minus this minus 3. So I'm just going to bring that down. And I believe that was a positive 2, right? Because a negative 5 plus 7 is a positive 2. So there, step 2 is done. And then operations have been formed. So I have a negative 3 plus a 2k. Are those like terms? No, I can't combine them. I'm done. So I'm kind of confused on the last one of like when operations have been performed. So like my guess is that, yeah, I don't know. I mean, I don't know when else you would have to change those, but I don't know. That's where I would leave it at. So I don't know what the third one is. But really it's just about getting rid of the grouping symbols and then to combining like terms. Sorry, give me 1 second. Okay, final one. Go ahead and take a second to try this one. Okay, I'm going to distribute this here, distribute that there. So I get negative 3x. Be careful, negative 3 times 5 is a minus 15 plus 3x. Combining like terms, I have a negative 3x here and a positive 3x there. What's negative 3x plus 3x? Be careful. So that's 0, right? So there was some people in class today that thought that I have to have an x term. Like I just have to. Like it makes sense. You don't have to, okay? So if I have negative 3x plus 3x, those are going to cancel, so I'm just left with negative 15. So that is my final answer. Some people were confused and they were concerned thinking that I had to have an x out here because there's a variable in the original expression, so I have to have a variable in my answer. That's not always the case. And this is one of those cases where that's not the case at all. Okay, so we didn't do this in class today or anything like that, so don't have to worry about that.